Welcome back to Maths Lab. In our previous video, we have discussed about question number 5 to 10 from first chapter, the use of coordinates, end of the chapter exercises. Today we are going to solve question number 11 to 16. So let's get started. Question number 11 is, let PQ be points of trisection of AB with P closer to A and Q closer to B. Using your knowledge of how to find the coordinates of the midpoint of the segment. How would you find the coordinates of P and Q? Do this for the case when the points are A 4, 7 and B 16, minus 2. So first we have to draw a line segment AB whose coordinates are given 4, 7 and B 16, minus 2. Then P and Q are 2 points of trisection of AB. On this line segment AB, there are 2 points P and Q. P and Q. Okay. They are trisections of AB. What is the meaning of trisection? P and Q, these 2 points divide this line segment AB by 3 equal parts. First part, this is the first part, second part and the third part. And P closer to A, P closer to A and Q closer to B. Therefore, we can write AP equals to PQ equals to QB. Okay. We have to find out the coordinates of P and Q. Let the coordinates of P x1, y1, Q x2, y2. By using midpoint formula, we have to find out the coordinates of P and Q. By midpoint formula. What is the midpoint formula? M equals M x comma y equals to x1 plus x2 by 2, y1 plus y2 by 2. Since P is the midpoint of AQ, P is midpoint of AQ, therefore we can write x1 equals to, x1 is the first coordinate of this midpoint P, so x1 equals to 4 plus x2, 4 plus x2 by 2, and y1 equals to y1 equals to 7 plus y2 by 2. Okay. This is number 1 equation, this is number 2 equation. Again, since Q is the midpoint of PB, Q is the midpoint of PB, Q is midpoint of PB, therefore we can write, see, now Q is the midpoint, correct? Q is the midpoint. So, first coordinate of Q, x2. x2 equals to what do we write? x1 plus 16 by 2. Similarly, y2 equals to y1 plus minus 2 by 2. So, you can write here x2 equals to x1 plus 16, x2 equals to x1 plus 16 by 2 and y2 equals to y1 minus 2, y1 plus minus 2 by 2. These are number 3 and number 4 equation. Now from equation number 3, we get x2 equals to x1 plus 16 by 2, correct? And from equation number 1, we get x1 equals to 4 plus x2 by 2. Now substitute the value of x1 in this equation. So we get, what is the value of x1 in number 1 equation? 4 plus x2 by 2. 4 plus x2 by 2. And here plus 16. Just substitute the value of x1, which is we get in equation number 1, and here by 2, denominator part by 2. Now solve this one. So get the LCM. What is the LCM here? 2. So simply the first part 4 plus x2 plus, there is nothing, means 1. So LCM is 2. So 16 into cross multiplication, 16 into 2, 32. Okay. And the denominator part simply 2. So now how can you solve it? See, on the numerator part, one fraction is there, as it is, you can write x2 plus 32 plus 4, 36. You can write here x2 plus 36 by 2. And the denominator part 1, 2 is there, correct? We know that any, suppose I am taking this by 1. Okay, so we know in the denominator part any fraction is there, so we can take this multiplication form and reciprocal of this fraction 1 2. When it comes on the multiplication form, the denominator is just ups and down, it comes 1 by 2. It's a reciprocal form. So x1, now simply multiply the numerator across and the denominator across. So x2 plus 36 by 2 to the 4. So this is actually x2, this x2. Okay. Now by cross multiplication, 4x2 equals to x2 plus 36. Correct. Now this x2 comes that side, 4x2 minus x2, 3x2 equals to 36. Okay. Therefore 3 comes that side, by divide form, 36 divided by 3 get 12. So what is the value of x2 we get? x2 we get 12. Okay. This is the value of x2. So now you take any equation, suppose equation number 1, and substitute the value of x2 and you get the x1. So find it from equation number 1. What is equation number 1? x1 equals to x2 plus 4 plus x2 by 2. 4 plus x2 by 2. Okay. So substitute the value of x2, which just now we have found it. So plus 12 by 2 equals to 12 plus 4, 16, 16 by 2, 8. So the value of x1 is 8. Okay. Value of x2 12, value of x1 8. So in the same way, we are taking equation number 4 and 2. See, in equation number 2, y1 is given. So in equation number 4, substitute the value of y1, and in the same way, we get the value of y2. Then once you get the value of y2, again you put the value of y2 in equation number 2 and you get the value of y1. So I am taking equation number 4. Now y2 equals to y1 minus 2 by 2. From equation 4, y2 equals to y1 minus 2 by 2. Correct. Now substitute the value of y1, which are in equation number 2. 7 plus y2 by 2 minus 2 whole divided by 2. Solve it. The LCM I am taking 2. 7 plus y2 as it is, minus, there is nothing, means 1. So only cross multiplication, 2 to the 4. 4 is there, and the denominator part 2. Okay. How do you solve? In the same way, y2 plus 7 minus 4, 3 by 2, and on the denominator part 2 is there. So in multiplication form, when it comes in multiplication form, 2 will be reciprocal 1 by 2 as reciprocal to 1 by 2. Now simply multiply the numerator part and the denominator part across. Y2 plus 3 and the denominator part 2 to the 4. This is equals to this Y2. Okay. Now cross multiplication 4y2 equals to y2 plus 3. Then 4 this y2 comes that side, it will get 3y2 equals to 3. Therefore y2 equals to 3 by 3 1. So we get the value of y2 1. From equation number 2. What is the equation number 2? 7 plus y1 equals to 7 plus y2 by 2. Substitute the value of y2 here. 7 y1 equals to 7 plus y2 by 2 equals to 7 plus y2 by getting 1 by 2 equals to 8 by 2 equals to 4. So y1 get 4. This is y1 and this is y2. The coordinates of T x1 y1 y1 4 8 4. So the coordinates of P 8, 4. Similarly, coordinates of Q x2, y2 equals to, put the value of x2. x2 is, this is x2 12 and y2 1. 12, 1. This is the answer of the question number 11. Let's do the question number 12. Question number 12 is, given the points A, B and C so that they lie on a circle K whose center is the origin O. What is the radius of the circle K? That is the first part of this question number 12. So first we am taking a circle K. A, B, C are 3 points on the circle. We have to check they are lying on the circle or not. So suppose I am taking A here, A point, and B I am taking here and C here. The coordinates of A are given A, B, C, 1, minus 8 for A, and for B, minus 4, 7, and for C, minus 7, minus 4. So how do you check they are lying on the circle or not? By using distance formula from origin. This is the origin. So first we have to check the distance of OA, then OB, then OC. So write distance of, this is the first part of this question, distance formula from origin. What is the distance formula from origin? Square root of x square plus y square. Because here is the another point, O is, the coordinates of O is 0, 0. That's why the from origin the distance formula will be square root of x square plus y square. Okay. Now find OA, square root of OA. Distance of OA. Then square root of 1 x square means here the value of x is 1, value of y minus 8. Then x square 1 square plus y square minus 8 whole square. Therefore 1 plus minus 8 whole square 64. So 1 plus 64 65. Square root of 65 units. This is the distance of OA. Similarly OB equals to square root of minus 4 whole square plus 7 whole square equals to minus 4 whole square 16 plus 7 square 49 equals to 6 plus 9 15 1 65. Total square root of 65 units. Similarly, OC, square root of minus 7 whole square plus minus 4 whole square. Minus 7 whole square 49 minus 4 whole square 16 equals to 6 square root of 65 units. Okay. Now you see the value of OA, OB, OC are equal, square root of 65 units. So they are lying on this circle K. So you can write OA, therefore OA equals to OB equals to OC equals to square root of 65 units. Therefore, the given points A, B and C lie on the circle K. This is the answer. And another thing is, what is the radius of the circle K? See, OA, OB, OC, they are actually the radius of the circle, correct? So, simply you write the value of OA, OB and OC, any of them. So, you write simply the radius of the circle is square root of 65 units. Radius of circle K is square root of 65 units. Now come to question number 12, second part. Given the points D and E, check whether D and E lie within the circle, on the circle or outside the circle. So how do you check? First find, suppose this is the circle, okay, K, and radius we know that, suppose OA, this is radius, square root of 65 we know, and D and E, there is 2 points are given, D and E. You have to check they are within this circle or outside of the circle or on this circle. Okay. If the distance of D and E from the origin is 65, square root of 65, that is equal to the radius, then definitely these 2 points are lying on the circle. But if outside of the circle they are lying, then it will be the greater than of square root of 65, greater than of the measurement of the radius. Okay. If it is within the circle, then its measurement will be the less than of the radius. So how do you check? First, to write the radius, which we already find out, 60 square root of 65 units. Okay. Then given points D, square coordinates are minus 5, 6 and E, the coordinates are 0, 9. Okay. Now find the distance of D from the origin, that means OD. Square root of minus 5 whole square plus 6 square. Using which formula? Distance formula from origin. Square root of x square plus y square. Okay. Now minus 5 whole square 25 plus 6 square 36 equals to square root of 61 units. First check D is within the circle or on the circle or outside the circle. See, the value of OD is square root of 61 and the radius of the circle square root of 65. Now since 61 square root of 61 less than 2 square root of 65, correct? So the given point D is lying within the circle, suppose here. Okay. So D lies within the circle. Okay. Now check OE, distance of E from the origin. Same formula. What is the coordinates of E? 0, 9. So 0 square plus 9 square equals to 81. Square root of 81 units. Now see, square root of 81 is greater than to square root of 65. That means OE greater than to radius. Therefore, E lies outside the circle. Outside the circle. Okay. So what you have to remember, if the given point, distance of the given point from the origin is greater than the radius, then it is lying outside the circle. If it is less than the radius, then it is lying within the circle. Now come to the next question. Question number 13. The midpoint of the sides of triangle ABC are points D, E and F. Given that the coordinates of D, E and F are 5, 1, 6, 5 and 0, 3 respectively. Find the coordinates of A, B and C. There is A, B and C. Three vertices of a triangle. Okay. And given B is the midpoint of AB side, E is the midpoint of BC and F is the midpoint of AC. The coordinates of midpoints, three midpoints are given. First D, 5, 1, for E, 6, 5 and for F, 0, 3. We have to find out the coordinates of A, B and C, the three vertices of the triangle. So how do you find? By midpoint formula. Let the coordinates of A, x1, y1, coordinates of B, x2, y2 and coordinates of C, x3, y3. Okay. Since D is the midpoint of AB, since D is midpoint of AB, therefore we can write D is the midpoint. Okay. Therefore we can write 5 equals to x1 plus x2 by 2 by midpoint formula. Correct. Similarly, 1 equals to y1 plus y2 by 2. So this one we can write x1 plus x2 by 2 equals to 5. First coordinates of the midpoint D. Similarly, we can write y1 plus y2 by 2 equals to second coordinates of D, that is 1. Now from the first one, x1 plus x2 equals to, by cross multiplication, 5 into 2, 10. This is equation number 1. And here y1 plus y2 equals to 2 into 1 by cross multiplication, 2. This is suppose equation number 2. Okay. Since E is the midpoint of BC, since E is midpoint of BC, therefore we can write 6 equals to x2 plus x3 by 2. Similarly, 5 equals to y2 plus y3 by 2. So, x2 plus x3 by 2 equals to 6 and y2 plus y3 by 2 equals to 5. So, here x2 plus x3 equals to, by cross multiplication, 6 to the 12 and here y2 plus y3 equals to 5 to the 10. Okay. Similarly, since and this is equation number 3 and equation number 4. Similarly, since F is the midpoint of AC, so we are writing So you can take 0 equals to x1 plus x3 by 2 and 3 equals to y1 plus y3 by 2. Since F is midpoint of AC, therefore x1 plus x3 by 2 equals to 0. y1 plus y3 by 2 equals to 3. Okay. That implies x1 plus x3 equals to 2 into 0 cross multiplication 0, and here y1 plus y3 equals to 3 to 2 6. This is equation number 5, equation number 6. So how many equations we are taking? 6 equations. First, second, third, fourth and fifth, 6. 6 equations. Now what we will do? Add the x1 part. Where we see the x1 part? See, we see x1 part, correct? Next we see here x2 plus x3 equals to 12. Equation number 3 and equation number 5 means only x coordinate, where we see the x coordinate x1, x2 and x3. These three equations we just add to each other. And in the other way we add the y coordinates, where y1, y2, y3 we are getting. Second number equation, fourth number equation and sixth number equation we have to add separately. First we add 1, 3 and 4, fifth equation. Okay. So you write add 1 number equation, 3 and fifth number equation. What do you get it? x1, simply you write the left hand side of the equation first, then equal sign, put the equal sign and add the right hand side part. So in left hand side part of these three equations are x1 plus x2 plus x2 plus x3 plus the fifth one, say x1 plus x3 equals to, now see the right hand side part of these three equations, 10, 12 and 0. 10 plus 12 plus 0 equals to 22. Correct? Now you see in the left hand side x1 and x1, 2 times x1. That means we can write 2x1, correct? Plus x2 also 2 times. That means we can write 2x2 plus x3 2 times. You can write 2x3. Now you take the 2 common from these three terms. So 2 if you take common, x1 plus x2 plus x3 equals to 22. Now this 2 comes that side by divide form. So in left hand side x1 plus x2 plus x3 equals to 22 by this 2 equals to 11. So you get x1 plus x2 plus x3 equals to 11. Correct? Now you see in the equation number 1, x1 plus x2 equals to 10. Correct? So put this value of x1 plus x2 on this last line here. See, x1 plus x2 from the equation number 1 we get 10. So put this value here, 10 plus x3 equals to 11. Now you get the value of x3. 10 you shift that side, 11 minus 10 equals to get 1. Therefore x3 equals to 1. Okay, this is the value of x3. Similarly, you can add equation number 2, 4 and 6. This 2 y part only. 2, 4 and 6. In equation number 2, y1 plus y2 equals to 2. Only add the left hand side part of this 3 equation. Then we get like that y1 plus y2 plus y2 plus y3 plus y1 plus y2. Then you add the right hand side part of these 3 equations. 2, 10 and 6. So 2 plus 10 plus 6 equals to 18. So similar way, here we can solve the, here we have solved the x1 part, okay. Same way we can solve it. y1 plus y1, 2y1, y2 plus y2, 2y2, y3 plus y3, how many times, no, this is 3, this is 3, y1 plus y3, okay. So y3 plus y3, 2y3. Therefore, 2 take common, y1 plus y2 plus y3 equals to 18. That implies y1 plus y2 plus y3 equals to 18 by 2, 2 shift this side, by 2 equals to 9. Therefore, y1 plus y2 plus y3 equals to 9. Now see the equation number 2. Here we get y2 plus, where is that? y1 plus y2 equals to 2. Substitute the value of y1 plus y2 equals to 2 plus y3 equals to 9. Therefore, we get the value of y3, 9 minus 2 equals to 7. That is the value of y3. Okay. Value of y3. So, value of x3, 1. Value of y3, 7. So, we can write like that. Value of x3, y3 equals to 1, 7. Okay. Keep it like that. Now you take equation number 3. Where is equation number 3? This one. x2 plus x3 equals to 12. Okay. x2 plus x3 equals to 12. Why? I am taking this equation because if you substitute the value of x3, just now we get, then you get the value of x2. That's why I am taking this equation number 3, x2 plus x3 equals to 12. So you write equation number from 3, x2 plus x3 equals to 12. Substitute the value of x3, x2 plus 1 equals to 12. Therefore, x2 equals to 12 minus 1, 11. Therefore, x2 equals to 11. Okay. And from equation number 4, y2 plus y3. Why I am choosing? Because if I substitute the value of y3, just now we get 7. So we get the y2 value. So y2 plus y3 equals to 10. This is the equation number 4. Now substitute the value of y3. y3 is 7 equals to 10. That implies y2 equals to 10 minus 7, 3. Therefore, y2 equals to 3. Now x2 equals to 11 and y2 equals to 3. So write it here, x2, y2, 11, 3. Okay. Similarly, from equation number 1, now we get x3, y3, x2, y2, only left x1, y1. So we choose equation number 1. x1 plus x2 equals to 10. Substitute the value of x2, x1, x2, what I get? 11. Okay. Put it here and get the value of x1. 10 minus 11. Therefore, x1 equals to minus 1. Okay, this is the x1. Now, equation number 2. y1 plus y2 equals to 2. Substitute the value of y2. y2 what I get? 3. 3 equals to 2. That implies y1 equals to 2 minus 3 minus 1. Therefore, y1 get minus 1. Okay. So, x1, y1 minus 1 minus 1. Therefore, x1, y1 equals to minus 1 minus 1. Therefore, a equals to, right, a equals to x1, y1 equals to minus 1 minus 1. b equals to x2, y2. What is the value of x2, y2? This one, 11, 3. 11, 3. And c, x3, y3 equals to value of x3, y3, 1, 7. 1, 7. So this is the answer of it. Question number 14 is, a city has two main roads which cross each other at the center of the city. These two roads are along the north-south direction and east-west direction. All the other streets of the city run parallel to these roads and are 200 meters apart. There are 10 streets in each direction. The number one question is, using 1 centimeter equals to 200 meters. Draw a model of the city in your notebook. Represent the roads or streets by single line. First we draw one main road, that is along with north-south. This is along with north and south. Another road along with east-west direction. And these two roads cross each other at the center of the city. This is the center of the city. All the other streets of the city run parallel to this road and they are 200 meters apart from each other. So total there is 10 streets in each direction. Let's draw the streets. So this is the street we are going to draw along with north-south direction. Total 10 streets we have to draw, in each side 5 streets. So blue line represent the north-south direction streets. This is the fourth one and this is the fifth one. So in the same way we have to draw in the other side 5 streets along with north-south direction. Number 1, number 2, and this is number 3 street, number 4, and that is number 5. Total 10 streets. Similarly, along with east-west direction, there are total 10 streets in each direction. So, in the east-west direction, number 1 street, number 2, number 3, number 4, number 5, and in this here also total 5. 1, 2, 3, 4, and 5. So the blue lines are in north-south direction and the green lines are the streets which are going to east-west direction. 1 centimeter equals to 200 meter. So this is 200 meter, this is 400, 600 like that. This side also 200, 400, 600 means 1 centimeter equals to 200 meter. The distance between two straights is 200 meter. In question number 14, number 1 part, they just ask to draw a model of the city in your notebook and represent the roads or street by single line. So they are, the blue lines represent the north-south direction street and the green line represents the east-west direction streets. And the two red lines that represent the two main roads, and the intersection of the two main roads is represent the center of the city. Now coming to the second part. The second part of question number 14 is, there are street intersections in the model. Each street intersection is formed by two streets, one running in the north-south direction and another in the east-west direction. Each street intersection is referred to in the following manner. If the second street running in the north-south direction and the fifth street in the east-west direction meet at the same crossing, then we call this street intersection 2-5. Okay, 2-5 is the intersection. Using this convention, find how many street intersections can be referred to as.
In this model, you have seen the street intersection. One street cross to another street. This point is called street intersection.
To find the first second street. Where is the second street? Second street is which is running in the north-south direction. So north-south direction, the second street is this one. Okay. And fifth street in the east-west direction. East-west direction, fifth. 1, 2, 3, 4, 5. And the second street here. East-west direction, fifth street, and the north-south direction, the second street meet in this point. Okay, that is 2, 5. This is the intersection point of the second street of north-south direction and the fifth street of east-west direction. So using this convention, find how many street intersection can be referred to as 4, 3. 4, 3. Where is the fourth number? 4. 1, 2, 3, 4. 4. And 3. 1, 2, 3. So this is the 4, 3 street. And we can refer only one street as 4, 3. Similarly, in number B, how many street intersections can be referred to as 3, 4? So where is 3? 1, 2, 3 and 4. 1, 2, 3, 4. So here is 3, 4 point where only one street intersection can be referred as 3, 4. So the number A answer is 4, 3. How many street intersection can be referred as? Only one. And number B, how many street intersection can be referred as 3, 4? Only one. So the answer is, we just write like that. For part A, one street intersection, one street intersects at 4, 3. And number B, only one street intersects at 3, 4. So the next question is number 15. Question number 15 is, a computer graphics program displays images on a rectangular screen whose coordinate system has the origin at the bottom left corner. The screen is 800 pixel wide and 600 pixel high. A circular icon of radius 80 pixel is drawn with its center at the point A, 100, 150 with coordinates. Another circular icon of radius 100 pixel is drawn with the center at the point B 250, 230 his coordinate. Determine whether any part of either circle lies outside the screen, whether the two circles intersect each other. First we create a Cartesian system here. This is x-axis, y-axis. Now we have to create a computer graphic screen on this Cartesian system. So the screen is 800 pixel wide and 600 pixel high. Let 1 unit equals to 100 centimeter. So this is 100, this is 200, like that 400, and this is 600. So, and here also 100, 200, 300, 600, like that. Okay. Here I am taking little more. This is 800, 700, this one. Okay. Now the screen is 800 pixel wide. Point the 800 on the x-axis. This is 800 wide and 600 pixel high. This is 600. Draw the screen of the computer. This one, just extend it, and this one extend it. So this is the screen of the computer, which is 800 pixel wide and 600 pixel high. Now a circular icon of radius 80 pixel is drawn with the center at the point A, whose coordinates are given 100 and 150. First we plot a point on this plane whose coordinates 100, 150. Where is 100? This one. So 100, 150, 100, and this is 150. So here is A. Another circular icon of a radius 100 pixel is drawn with the center at the point B. Now you have to plot B point whose coordinates are 250 and 230. 250 on the x-axis, this is x coordinate of 250 and 230 y coordinate. 100, 200, 230 is here. Okay. So this is B. Now the first circle whose radius is 80 pixel, that is 0.8 centimeter radius. You have to take 0.8 centimeter radius and at the point A as a center, take at the point A as a center and 0.8 centimeter radius, you have to create a circle. Where is A? There is A. Okay. Now I am taking 0.8 centimeter with the help of the scale, 0.8 centimeter at the point A as a center. So 0.8 is here is 0.8. Okay. So point A and we have to create a circle like that way. Okay. Next, at the point B as a center, you have to draw another circle with radius 100 pixel. 100 pixel means 1 unit. Okay. 1 unit, you take the radius at the point B as a center. So with the help of a scale, I am taking 1 unit. 1 unit means here 1 unit. Now I am drawing another circle like that way. You have to create two circles. One radius is 0.8 centimeter or 80 pixel. Another is 1 centimeter or 100 pixel. That is B as a center of B. Now determine whether, first part is whether any part of either circle lies outside the screen. This is the screen. Okay. This is the screen of this computer. The two circles are lie within the screen, not outside the screen. So our first question answer will be no. You have to write the answer of the first part. No. Part lies outside of the screen. Okay. And the second part, what is the second question? Whether the two circles intersect each other? Yes, two circles intersect each other. So, because there is touch, we do circle touch here now. So, two circles intersect each other. We write yes, two circles intersect each other. So, first you take the unit as a 100 pixel, 1 unit equals to 100 centimeter, like that. Then you take the measurement of the screen length and breadth. 800 is the breadth and the length is 600 height. Then you plot two points A and B. The coordinates are given. Then take A point as a center and radius 80 pixel, that is 0.8 centimeter. Draw a circle and take another point P as a center and with radius 100 pixel, that means 1 unit. Draw another circle. After that you just judge they are intersect each other or not, and they are lying outside of the screen or inside of the screen. So they are lying inside of the screen and they touch to each other or they intersect to each other. That is the answer of the question 15. Next come to the question number 16. Question number 16. Plot the points A, B, C and D whose coordinates are given in the coordinate plane. Is A, B, C, D is a square? Can you explain why? What is the area of this square? Here 4 points are given. A equals to 2, 1, B minus 1, 2, C minus 2, minus 1, D 1 minus 2. First we have to find out AB, distance of AB using distance formula. What is the distance formula? X2, square root of x2 minus x1 whole square plus, distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So using this formula we have to find out AB minus 1 minus 2 whole square plus 2 minus 1 whole square equals to minus 1 minus 2 minus 3 whole square 9 plus 2 minus 1 1 square 1. So it is equals to square root of 10 units. Similarly BC, B and C minus 2 minus 1 plus 1 whole square plus minus 1 minus 2 whole square. Okay. Then minus 2 plus 1 minus 1 minus 1 whole square 1 plus minus 1 minus 2 minus 3 minus 3 whole square 9. So it is equals to also square root of 10 units. Next CD equals to C and D points are given. So 1 minus plus 2 whole square plus minus 2 minus plus 1 whole square equals to 1 plus 2 3 square 9 plus minus 2 plus 1 minus 1 whole square 1 equals to square root of 10 units. Similarly, AD or DA equals to square root of A and D. Points are 2, 1, 1, minus 2. That means AD, so 1 minus 2, x2 minus x1 means 1 minus 2 whole square plus minus 2 minus 1 whole square. Minus 2 minus 1 whole square. So we get 1 minus 2, 1 minus 1 minus 1 whole square 1 plus minus 2 minus 1 minus 3 whole square 9. So it is equals to square root of 10 units. Now you observe the value of AB, BC, CD and AD. They are the four sides of the square if it is a square. So the value of these sides are equal, square root of 10 units. Another thing you have to check the diagonals of the square. This is the square. A, B, C and D. All sides are, we are getting square root of 10 units. Okay, all sides are equal. But we have to check another thing, the diagonal of this figure. We have to find out the length of the two diagonals. AC equals to, we have to find what is AC? A and C. So 2 minus 2. X2 is minus 2, X1 2. Minus 2 minus 2 whole square plus y1 is 1 and y2 is minus 1. Minus 1 minus 1 whole square. So minus 1 whole square. So minus 2 minus 2 minus 4. Minus 4 whole square 16 plus minus 1 minus 2. Minus 2 whole square 4. So it's getting 20. Square root of 20 units. Similarly, another diagonal BD. What is the length of it BD? Coordinates of BD are minus 1, 1, x1 minus 1, x2, 1. That means 1 minus minus plus 2. 1 plus 2 whole square plus minus 2. This is minus 2 and 2. Minus 2 minus 2 whole square. Therefore, 1 plus 1, 2, 2 square 4. Minus 2 minus 2 minus 4 whole square 16. Therefore, square root of 20 units. Now you see AC and BD both are diagonals of the square. So they are also equal. Therefore, ABCD is a square. So, therefore, since AB equals to BC equals to CD equals to AD are equal, that is square root of 10 units, and also the diagonal AC equals to BD, they are also equal, square root of 20 units. Therefore, ABCD is a square. Okay. Another question is, what is the area of this square? What is the formula of the area of the square? Side square. So area is side square. What is the side length of the side? Square root of 10. Whole square equals to 10 square units. This is the answer of each question. So all the questions of this chapter we have already completed. Any doubt you can comment me. I'll definitely clear your doubt. Thank you.